All right, so now we're going to be reviewing transformation. So one of the things that we talked about was similarity versus congruency. So when you have similar figures, that means you have same shape, different size. And then when you have congruent figures, that means you have same shape, same size. All right. Now the rules for a translation. So remember, translation just means that you're sliding a figure. So your x coordinate determines your left or right distance. So the horizontal distance, I guess I should say. Which means your y coordinate determines your vertical distance. So up or down. So the rule is your x is going to be plus or minus whatever you're moving left or right, and your y is going to be plus or minus whatever you're moving up or down. So for this one, how does the rule x minus 2, y minus 4 change the pre-image? So x, remember, means you're going left or right because you're going on the x-axis. If it's a minus, that means you're heading towards the negative, so you're going to go left 2. So you're going to go left 2 on the x-axis. And then y minus 4, so y is going up and down, and if it's a minus, that's heading towards the negative, so you want to go down, and you're going to go down 4. Okay, and then remember with a translation, whenever you're just moving a figure, you're still going to have same shape, same size, so you're still going to get congruent figures. All right, so let's just do a couple of examples. So this says to translate 2 units right and 3 units down. So I'm going to label my vertices first. So let's say this is A, this is B, and this is C. So I'm just going to count 2 units right and then 3 units down, and that's where my prime's going to be. So 2 units right and 3 down. So A prime is going to end up here. And then just do the same with your others. So 2 right, 3 down. B prime is going to end up here. And then C prime, 2 right, 3 down. So when you finish, you should still have the same shape and the same size. All that happened was your triangle moved. So it slid. And that's what that figure should look like. Okay, so now we're going to do the same thing with this rectangle. So again, I like to label my vertices so I know where to go and how to label it. Now this rule, they say x plus 6, y plus 5. So x plus 6 means you're going to the right 6, and y plus 5 means you're going up 5. So you're taking each of your points and go right 6, 1, 2, 3, 4, 5, 6, and up 5, 1, 2, 3, 4, 5. So A prime is going to end up at 0, 4. And then you're just going to keep doing that with the rest of your vertices. So right 6, 1, 2, 3, 4, 5, 6, up 5, 1, 2, 3, 4, 5. So there's B prime. C prime, so negative 3, negative 4, it moves right 6, 1, 2, 3, 4, 5, 6, and up 5, 1, 2, 3, 4, and 5. And then the last one, D prime. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And again, when you finish, you should still get the same shape, same size, because they are congruent figures. All right, so that is translations. So now we're going to move on to dilations. So dilations means you're either enlarging or reducing of figures. And this is when you are going to get similar figures, because you are going to get same shape, but you are going to get a different size. Okay, so the rules is when you have a scale factor, you're going to multiply your scale factor with your x and your y values, so it goes to both values. If you have a scale factor that is larger than 1, that means that it's going to be enlarged. And then if you have a scale factor that is less than 1, your scale factor is going to be reduced. So your image is going to be reduced. Okay? So the first one, dilate by a scale factor of 1/2. So if I were to get all of these order pairs for A, B, and C, A is at 2, 6, B is at 2, 2, and C is at 6, 2. So if I want to dilate by a scale factor of 1/2, all that I'm doing is I'm taking each of these numbers and multiplying them times 1/2. Or multiplying times 1/2 is the same thing as just dividing by 2. So my A prime, if I divide both these numbers by 2, 2 divided by 2 is 1, and 6 divided by 2 by 3. So A prime is going to end up at 1, 3. Do the same thing with B, so multiply both these numbers times 1/2. So 2 times 1/2 is 1, and 2 times 1/2 is 1. So B prime is going to end up at 1, 1. And then C prime, 6 divided by 2, or 6 times 1/2 is 3, and 2 times 1/2, or divided by 2, is 1. So C prime will end up at 3, 1. So you should still get the same shape. Okay, so notice how I still got the same triangle. It was just reduced, so they were just different sizes, hence why they are similar. Alright, so let's try the same thing with the next one. So dilate by a scale factor of 3. So again, I'm just going to get my order pairs over here. So we have P, R, Q. P is at 1, 3. R is at 1, 1. And Q is at 3, 1. So this time I have a scale factor greater than 1, so my image is going to get bigger. So all that I'm going to do is I'm going to take my scale factor of 3 and multiply it times every single number in my parentheses. So 3 times 1 is 3, and 3 times 3 is 9. So P prime is going to end up at 3, 9. R prime is going to be at 1 times 3 is 3, and 1 times 3 is 3, so it's going to end up at 3, 3. And then Q prime, so 3 times 3 is 9, and 1 times 3 is 3. So Q prime is going to end up at 9, 3. So let's plot it. So P prime is at 3, 9. R prime is at 3, 3. And Q prime is at 9, 3. So again, when you get done, you should still get the same shape, but it's just a different size. All right, moving on to reflection. So the rule is when you reflect over the x-axis, you multiply y times -1. So that's x comma -y. And then when you flip over the y-axis, you multiply x times -1. So there's a couple different ways that you can do it when you're looking at your coordinate plane. You can do exactly what we did on the back side with dilations by getting all of your order pairs. So we have D, E, F, and G. So D is at 1, 3. E is at 5, 3. F is at 7, -1. And G is at 1, -1. And what you can do is to figure out all of your primes. So in this case, if we're reflecting over the x-axis, remember you're multiplying y times -1. So you're just going to take all of your y values and multiply them times -1. So x stays the same. 3 times -1 is -3. X stays the same. 3 times -1 is -3. 7 stays the same. -1 times -1 is +1. And then your 1 stays the same, and -1 times -1 is a +1. Okay, then we can just plot it from here. So D prime is now at 1, -3. E prime is at 5, -3. F prime is at 7, 1. and G prime is at 1, 1. So notice how when you reflect, your pre-image and your image just look like a mirror. Okay, so they just reflect like a mirror, and that's all that you have to do. Okay, so that's one way of doing this, is by to actually just take the original order pairs, and then if you're reflecting over the x, you multiply all your y's times -1, and then you can plot them. Or for this one, we'll do it the other way. So again, I'm just going to label them A, B, C, D. And if you're reflecting over the y-axis, so here's my y, so this is where my mirror is at. Your image, if it's over here, should end up on this side. So if you're reflecting over the y, you're just counting how many units your vertices are over. So for example, if A is at 1, 4 and I need it to go on this side, it still has to be 1 unit over, but it's going to stay at the same y spot. So A prime is going to be on this side at -1, 4. B prime was 5 units away from where the y-axis is at, so when I flip it over here, it still has to be 5 units away from the y-axis. And it's still going to stay at the same height. C prime was 2 units away, so C prime is still going to be 2 units away over here from the y. And then D, it was 4 units away, so D prime is still going to be 4 units away over here. So when you get done, again, it's going to look like a mirrored image. And notice how you still get same shape, same size, so when you are reflecting, you are going to get congruent figures. Alrighty, and the last one that we talked about here is a rotation. So rotation, you're just churning. So the rule is when you are going 90 degrees clockwise, you are multiplying x times -1, and then you are flip-flopping your coordinates. So it's going to be y comma -x. 180 degrees rotation, doesn't matter if it's clockwise or counterclockwise. You just multiply both of your values times -1, and you don't flip-flop. And then a 270 degree clockwise rotation is the same thing as a 90 degree counterclockwise rotation. And you're just doing the opposite of the clockwise. So instead of multiplying x times -1, you multiply y times -1, and you still flip-flop your values. Okay? So this one, I do like to write down the order pairs because it makes it a little bit easier for me. So here we have a fish, and it has vertices of A, B, C, D. A is at -2, 2. B is at -5, 3. And C is at -5, 1. So the rule is if we want to rotate 90 degrees clockwise, we multiply our x value times -1, and then we flip-flop. So A prime, if I multiply x times -1, -2 times -1 is 2, and then flip-flop my value, so A prime is going to end up at 2, 2. B, multiply x times -1, so -5 times -1 is 5, and then I can flip-flop, so B prime is going to be at 3, 5. And then C, multiply x times -1, so -5 times -1 is 5, and then flip-flop my values. So C prime would be at 1, 5. Then all I have to do is plot them. So A prime is at 2, 2, B prime is at 3, 5, and C prime would be at 1, 5. And I'm not the best at drawing, so I'm just going to guess it's going to look something like this. I didn't put my triangles in the right spot. There we go. So there's my fish. So as you guys can see, all that it did was it just rotated 90 degrees clockwise. It went from here, and then it rotated down there. Okay? And then our last one, so rotate 270 degrees clockwise. So 270 degrees clockwise is the same thing as a 90 degrees clockwise or counterclockwise rotation. So this rule is you're multiplying, oh, sorry, I just realized I did this wrong. So a 90 degrees counterclockwise rotation is you're multiplying y times -1 and then flip-flopping your values. So this, let me just rewrite it, should be -y comma x. Sorry about that. I realized that these were the same thing. I was like, oh, that's not right. Okay. So now our rule for a 270 degrees clockwise rotation is the same as 90 degrees counterclockwise. You're multiplying y times -1 and then flip-flopping your values. So let's go ahead and do the same thing as we did for the first example, is to get all the order pairs. So A is at 2, -2. B is at -2, 5. And C is at -4, 2. So to get my primes, again, all that we're doing is we are multiplying our y value this time times -1 and then flip-flopping. So -2, since that's my y value, -2 times -1 is 2. Flip-flop my values, and A prime is now at 2, 2. B is at -2, 5. So you can multiply your y times -1. So 5 times -1 is -5. Flip-flop your values, and you get -5, -2. And then our last one here, so C prime, if you multiply 2 times -1, that's -2. Flip-flop your values, and you get -2, -4. Okay, so last thing here is we just have to plot them. So A prime is going to end up at 2, 2. B prime will end up at -5, -2. At -2, -4. So again, when you are rotating, you should still get the same shape, same size, so you are still going to get congruent figures. And that is it. So if you guys have any questions, please let me know.